Math 1332, Chapter 2, Set Theory, Section 2.2, Subsets and Set Operations, Video 4, Subsets. I've kind of alluded to subsets already. When I said that A was a set inside of a universe, I was saying that A was a subset of the universe. And even in the previous section, I had made some allusions to subsets. I even specifically made an allusion to what was called a proper subset when I was showing an alternate definition of verifying that a set was infinite by showing it could be put in one-to-one correspondence with a proper subset of itself. After this video and the next video, you may want to go back and revisit that final video from section 2.1. It'll make a little bit more sense when I say proper subset. But let's start by defining what I mean by a subset. Subset is a relationship between two sets. It's not like an operation where you take two of something and create a new one. It's saying, are these two sets related in a certain way? Set A is a subset of set B, written symbolically as this, which would be read A is a subset of B. The symbol for subset looks like a capital U opening towards the right with the horizontal line underneath it. It kind of looks like a capital C, but it really is more like a capital U opening to the right with a line underneath it. Set A is a subset of set B, written symbolically as A is a subset of B, means that every element of A is also an element of B. In other words, if you belong to the first set, then you must belong to the second set. In other words, if A is an element of B, then, in other words, if X is an element of A, then X must also be an element of B. We'll talk about this equivalent statement in just a moment. But think of it this way. If you're watching this video, then you are an element of all the people who have ever watched videos on YouTube. But all of the people who have ever watched videos on YouTube are a subset of all of the people on the planet Earth. Because if you are a person who has watched a video on YouTube, then you must also be a person living on Earth. Correct as of today's date. In the future, Lord knows what will happen. Or here's another example. Dogs, all dogs are mammals. So dogs are a subset of mammals, because if you are a dog, then you must also be a mammal. Now notice the reverse is not true. All mammals are not dogs, meaning if you're a mammal, it doesn't mean you're a dog. However, if you're a dog, then it means you're a mammal. So the set of all dogs is a subset of all mammals. There's an equivalent way to saying you're a subset, not by talking about what you must belong to, but about what you must not belong to. The standard way of thinking about a subset is if you belong to the smaller set, then you must belong to the larger one as well. You can also say it means if you don't belong to the larger set, then you don't belong to the smaller set either. For example, if you're not a mammal, then you're certainly not a dog. Why? Because dogs are a subset of mammals. Now, if you're thinking there's a Venn diagram picture for this, you are correct. But we're going to see that in the next video. In the meanwhile, we're going to take a look at a few examples and then make some observations. For our first example, let's take a universal set containing the whole numbers from 1 through 10. Set A will consist simply of the numbers 2, 4, and 8. Set B consists of the numbers 2, 4, 6, 8, and 10. And set C consists of the numbers 1, 2, 4, and 8. And my question is, which sets are subsets of other sets? Or which sets are contained inside of a larger set. Let's start with set A. Is set A contained in the universe? Well, wait a minute, all of these are contained in the universe. So instantly we can say A is a subset of U. By default, any set in a universe must be a subset of that universe. So all three of these are subsets of the universe. But let's look at relationships not involving the universe. Is A a subset of B? Which is like asking, is everything in A also in B? Well, we can check. Excuse me, number 2, do you belong to B? Yes, I do. Excuse me, number 4, do you belong to B? Yes, I do. Excuse me, number 8, do you belong to B? Yes, I do. Since every one of these is also contained in B, that means that A is a subset of B. Is A a subset of C? Is every element of A an element of C? Well, we can check again. Excuse me, element of A, do you belong to C? Yes. How about you? Yes. And you? Yes. Since every element of A is also an element of C, then A is a subset of C. Is B a subset of C? Does every element of B belong to C? Well, it might be obvious, but if it isn't, we can check by asking every element of B a question. Do you belong to C? Excuse me, first element of B, do you belong to C? Yes, I do. Excuse me, next element of B, do you belong to C? Yes, I do. So far, so good. Excuse me, next element of B, do you belong to C? No, I don't. 6 is an element of B that does not belong to C. And it only takes one element to say you are not a subset. Now, how do we say that B is not a subset of C? It's not that hard to imagine. You take the subset symbol and draw a slash through it. B is not a subset of C. Are there any other subset relationships that I've missed? A is inside of B, A is inside of C, everybody's inside of U. C is not inside of A, C is not inside of B, B is not inside of A. Oh, well, there are some trivial ones. For example, C is a subset of someone besides the universe. C is a subset of itself. Meaning, if I go to each element of C and ask it, are you in C? They would all say yes. Excuse me, are you in C? Yes. Are you in C? Yes. Are you in C? Yes. They're trivially in C. So it would be correct to say that C is a subset of itself. Same thing with B, same thing with A, same thing with the universe. That's actually one of the, excuse me, I meant to write A as a subset of A. But it's kind of trivial to say that a set is a subset of itself. Because if you belong to a set and then I ask you, do you belong to that set? The answer has to be yes. That's actually one of our observations. For any set, we'll call it A. A is a subset of itself. It's one of our observations. But I don't think there's any more subset relationships besides the universe as a subset of itself that we can write using U, A, B, or C. In the next example, all I've got written are the natural numbers. Remember, these are the numbers that you count with, 1, 2, 3, and 4. If you don't remember the natural numbers, the whole numbers, I recommend going and watching the second video for section 2.1 about special sets of numbers, because I'm not going to write them all out here. I'll say them. The natural numbers are 1, 2, 3, 4, and so on. Do you remember what the next set of numbers? What the next set of numbers was? The whole numbers, which were 0, 1, 2, 3, and 4. But isn't every natural number also a whole number? Yes, which means the natural numbers are a subset of the whole numbers. And what was the next set of numbers after that? The integers, which included the whole numbers and their negatives. Isn't every whole number also an integer? Yes, which means the whole numbers are a subset of the integers. And the next set of numbers were the rational numbers, the fractions. But remember, every integer is also a rational number because every integer, like -3, can be written as the ratio of whole numbers, ratio of integers, by simply putting it over a 1, meaning that every integer is a rational number, which means z is a subset of q. As decimals, q were all the decimals that either ended or repeated, but the real numbers were all decimals, regardless of whether they ended or repeated. So the rational numbers are a subset of the real numbers. And without hurting your head much more, there is a larger set than the real numbers, but it involves complex numbers and is beyond the discussions in this course. So I just wanted to show you that all the special sets we had subset relationships. And the subset relationship is sort of transitive in the sense that if one set is a subset of another, and that one's the subset of a third set, then the smallest is the subset of the largest. In other words, I can bypass any guy in the middle and say something like the natural numbers are a subset of the integers. Or I could say the whole numbers are a subset of the real numbers. Which brings me to observation number 2. If A is a subset of B, meaning A is contained inside of B, and B is a subset of C, meaning that B is contained inside of a larger set, then A is a subset of B. If you think about subsets as one collection being inside of another, that last thing is pretty easy to see. For example, this is a container of wipes that I use to clean the board. Currently there are no markers in it, but I'm going to take this set of markers and I'm going to put it inside with the wipes. And so now the set of markers is a subset of this set. But now I'm going to take this set and put it inside the trash can with more objects. And so now this set is a subset of this one. Are there markers inside the trash can? Yes, which means the markers are a subset of the trash can. That's all this is saying. If one thing is inside of something else, but that thing is inside of a larger object, then the smallest object is inside of a larger object. I'm sorry, this last thing was supposed to say, then A is a subset of C. So if you wrote that down, and I hope you're writing this down, that should have said A is a subset of C. If one set is inside of the larger one, and the larger one is inside of yet another larger set, then the smallest set is inside of the largest set. I thought there was one more. Oh, yeah. There's one more observation I wanted to make, and this one's kind of tricky to explain, but it kind of goes back to this alternate definition of being a subset. The idea is you're a subset if everything inside of you is inside of a larger set. But vice versa, if you're not in the larger set, then you're not in the smaller set. Such as the example saying, if you're not a mammal, then you're not a dog, because dogs are subsets of mammals. Third observation, the empty set, and let me preface this. For any set A, the empty set is a subset of A. Now, how can I justify that? It's hard to explain by saying if you're in the first set, then you're in the second set, because nobody belongs to the empty set. However, the alternate definition says if you're not in the larger set, then you're not in the smaller set. If you are not in this set, then you can't be in this one either, because this one doesn't have anything. This is what would be said to be vacuously true. It's true in the sense that there are no elements here to check to see if they belong to the larger set. Just remember, the empty set is a subset of every